Welcome to 24 Hours of PaaS, Evolution of the Data Platform. We're excited you could join us today for a Jeremiah Wilton session. 4 reasons to migrate your SQL Server databases to the cloud: security, agility, availability, and reliability. This 24 Hours of PaaS event consists of 24 consecutive live webcasts delivered by expert speakers from the PaaS community. The sessions will be recorded and posted online after the event. To access any on-demand sessions, please visit www.24hoursofpaas.com for all session links. My name is Hamish. I'm the moderator for this session today. I am based in Christchurch, New Zealand, so it's coming up 9 AM my time on Thursday. I'm a PaaS chapter leader here in Christchurch and a speaker at SQL Saturday. And funnily enough, after this session's finished, I'm going to be jumping on a plane to Brisbane, Australia. I've got a few introductory slides here which I'll talk through before I hand over the reins to Jeremiah. Alrighty. If you require any technical assistance, please type your question into the question pane located on the right side of your screen, and someone will come along and assist you. This question pane is also where you may ask any questions throughout the presentation. Feel free to enter your questions at any time, and once we get to the question and answer portion of the session, I'll read your questions back aloud to the speaker. You're able to zoom in on the presentation content by using the zoom button located on the top of the presentation window. Please note that there will be a short evaluation at the end of the session. Your feedback is really important to us, so please take a moment to complete it. It'll also appear in your web browser. Righty. I'd like to take a moment to thank our presenting sponsors, Microsoft, Redgate, Hortonworks, and Amazon Web Services. Amazon Relational Database Service, or Amazon RDS, makes it easy to set up, operate, and scale Microsoft SQL Server databases in the cloud. It provides cost-efficient and resizable capacity while managing time-consuming database administration tasks, freeing you up to focus on your applications and business. In addition, I'd also like to thank the supporting sponsors of this event, Hewlett-Packard Enterprise, SQL Sentry, and SanDisk. The staging of 24 Hours of PaaS would not be possible without their generous support, and they are the reason this event is available free of charge. Alrighty. Make sure you explore everything else PaaS has on offer for data professionals. You can join local user groups around the world, special interest groups, find free online resources through our Learning Centre, and read up on the latest community news in the Connector newsletter. Alrighty, introducing Jeremiah Wilton. Jeremiah is a principal database engineer at Amazon Web Services. As you see, he's got 20 years experience designing, building, deploying, and managing business-critical enterprise-class systems. He was Amazon.com's first database administrator and key architect of Amazon's data systems beginning in 1997. So what I'm going to do is hand over to Jeremiah now to take the session. So over to you, Jeremiah.
Thanks very much, Hamish, and thanks for that nice introduction. I'm going to cover a few topics today. First of all, I'm going to provide a basic primer on AWS and our services so you can understand the building blocks that we provide. And we'll also explore some of the ways that customers can run SQL Server on AWS, since there's actually more than one way to do it. We're going to talk about how to use AWS to meet your requirements around performance and security. And we'll also discuss considerations of running performance-intensive workloads at scale on AWS. So first, let's take a quick look at what AWS consists of. AWS is a cloud computing platform. We provide a variety of services to companies, the public sector, individuals. We have over 70 distinct cloud services ranging from utility computing, such as EC2, which many of you may be familiar with, storage and content delivery, such as S3 and CloudFront, managed database services, such as RDS SQL Server and other database engines, networking services, such as virtual private cloud, analytics services, enterprise SaaS applications, services around the Internet of Things, mobile, dev tools, system management tools. We have security and identity services, services for integration and email and message queuing. Just all in all, it's a very broad and deep platform. We've built it and engineered it in an effort to try to allow customers to build just about any kind of application that they might need, from the all the way to the most sophisticated, resilient, and scalable systems that might be required. Our global customer base pays for AWS resources using a utility model, which is one of the key differentiators of cloud computing. It means that you pay only for those resources that you use, and only for the amount of time that they're in use. We were really pleased to see Gartner's most recent Magic Quadrant for infrastructure as a service, where they reported that AWS has more than 10 times the compute capacity and use than all the other cloud providers in that quadrant combined. Many of our customers moving from conventional hosting environments are finding that the way they spend their engineering time changes quite a bit when they move to AWS. With conventional hosting, they spend time and resources managing the infrastructure, doing maintenance, deployments, patching, managing backup and recovery. These are all things that are not central to the business's mission. We call these things undifferentiated heavy lifting. We found that customers spend dramatically less time doing that kind of undifferentiated heavy lifting when they move to AWS. This means more agility for our customers, and increased agility has become the #1 reason businesses have come over to us. Customers use AWS for quite a few different kinds of workloads, but they typically fall into a few categories. One is deploying new apps and workloads and services. And an example of that is Netflix, one of our major customers. Another is migrating existing apps and data into the cloud. And an example of that is Intuit, another one of our great customers. And they're moving everything into AWS. And another use case is augmenting on-premises resources with cloud capacity. It's effectively employing a hybrid cloud strategy. So AWS's infrastructure is global, as many of you know. Our customers are able to deploy workloads on 5 continents. For those who are unfamiliar with our services, we treat our regions a little bit differently than other providers do. A region is basically a geographic boundary. And within a region, customers can provision resources. The regions are completely independent and isolated from each other. And that means that they provide data sovereignty. You get to decide where your data is housed. We've got 12 regions, and each of those regions has 2 or more availability zones. We abbreviate those AZ, availability zones. And the AZ is a distinct location, isolated and independent within a region. AZs are the cornerstone of our approach to high availability. Each AZ is located on a distinct floodplain and on a distinct power grid, but all AZs within a region are close enough to each other to provide very low latency network communication. You can think of an AZ more or less as a data center virtually. So with AWS, you can deploy workloads across multiple AZs in order to mitigate the effects of failures, such as a failure within an AZ. On top of the global infrastructure, we offer a variety of services that customers can use to rapidly build or re-engineer applications. We offer foundational services such as compute services, in other words, VMs, storage services, security, access control, networking. On top of these core services, we offer a set of higher level platform and managed services for a variety of needs, including running managed databases, including SQL Server. It can be a little bit overwhelming working with us and trying out AWS for the first time if you aren't familiar with the landscape of our technology. You can be confronted by multiple services
We seem to have lost Jeremiah. We'll just see if we can get him back.
come into play, even when you're just trying to do one thing like run SQL. Are you there? Can you hear us? Hamish?
We can now. You broke up a bit there, and your video froze.
All right. So I'm going to stop my video to maintain bandwidth in case that's the issue, and then I'll just continue.
Okay. Thank you.
Do speak up and give me a heads up if there are any further audio issues.
Yeah, if anyone does have audio issues, please put it into the chat window or frame it as a question, and we'll look after you. Cheers.
Okay, sorry about that. In any case, I was talking about launching RDS SQL Server on AWS. You can, RDS, as I mentioned, is our relational database service, and it provides a fully managed database as a service. And we provide not just SQL Server, but also Oracle, MySQL, MariaDB, Postgres, and our own enterprise-class MySQL compatible database engine, Aurora. But RDS is not the only way to run SQL Server on AWS. You can actually just run a compute VM, which we call an instance of Windows, in our service called EC2, the Elastic Compute Cloud. That's our virtual utility computing service where you can install and manage SQL Server yourself, just like you would do on any other host. In addition to that, there are several other AWS services and components that sort of come into play to provide some of the capabilities you would typically need when running an application or a database. And one of those is the Virtual Private Cloud, VPC, which provides private networking for you, for all of your AWS assets. You can carve out your own isolated section of the cloud with your own network topology and addressing and traffic and filtering rules. And then there's IAM, Identity and Access Management, which provides granular access control to the users that might need to set up and work with your AWS assets. But how are you as a customer supposed to decide between, say, running RDS SQL Server or running self-managed SQL Server on EC2? Like, what are the factors that you might want to consider when making that decision? Well, let me talk about that. More and more customers we talk to are adopting what we call a cloud-first policy. And what that means is they have a workload that can run in the cloud, then they do deploy it in the cloud. So we kind of have a similar thinking around RDS versus EC2 when it comes to SQL Server. Unless you have a use case that absolutely can't run on RDS, then run your databases on RDS. It's got a lot of great automation that you would otherwise have to implement and build or have already built yourself. Because RDS is a fully managed database service, it gives you the opportunity to focus more on your business and goals rather than the database management. There are some customers for whom RDS is not a perfect fit. Some customers need full SA access to the system, for instance, a system administrator access. Others have very specific backup or replication strategy that they need to do that we don't support on RDS for one reason or another. So once you understand what RDS does provide and you find that it doesn't meet your needs, then running SQL Server on Amazon EC2 is a perfectly valid option. For instance, if you need to run SQL Server analysis services or integration services or one of the other ecosystem services not included in RDS, then EC2 is a great choice. So, like I mentioned, there are two ways to run SQL Server on AWS. RDS is something you can use to provision a fully managed SQL Server instance where we take care of that undifferentiated heavy lifting and leave you to focus on your core business missions. Or you can deploy SQL Server on EC2 yourself and manage your own instances. Let's take a look at some of the capabilities of SQL Server on RDS versus EC2. So when you're making the decision how to run SQL Server on AWS, you want to consider which version of SQL Server you need to run. RDS tends to cover sort of a narrower band of more recent versions. Either way you go, 4 editions of SQL Server are supported. And another really nice feature of SQL Server is how simple it is to set up multi-site high availability. When you launch an RDS instance, there's a single checkbox that allows you to enable multi-AZ asynchronous replication. Under the covers, this uses SQL Server database mirroring, a feature many of you might be familiar with. If you deploy on EC2, you can also use always on or log shipping as well. Both RDS and EC2 support encryption for all SQL Server editions using our key management service, KMS. And for those of you running Enterprise Edition, you can use transparent data encryption on both RDS and EC2. We support full Windows authentication as well as SQL Server internal authentication on both RDS and EC2. For backup and recovery, one of the great advantages of RDS is that you have a fully managed backup and recovery to any arbitrary point in time capability. You simply tell the API or the web console where you want it restored to, and it restores it, and it does all the backups in an automated fashion in the window that you designate. With EC2, there are some things you can't do on RDS, such as maintenance plans and third-party tools running on the same machine. Another great thing about RDS is we do automated software patching and upgrades and that kind of stuff. If you self-manage your SQL Server on EC2, then you'll have to do all that yourself, more or less. So let's get down to the nuts and bolts and find out exactly how customers deploy SQL Server on AWS. How would you actually go about doing it? One of the things that makes AWS a real cloud is the fact that everything on our platform is API manageable. It means you can use the web-based management console to manage AWS resources, or you can script it out using the AWS command line interface or PowerShell. You can also build your own management and automation tools using the language of your choice, using the AWS software development kits. Or you can even deploy entire stacks of technology services with a service on AWS called AWS CloudFormation. Security is a paramount concern for AWS, and it probably is for you as well, both in a conventionally hosted environment and in the cloud. For AWS, security is always our top priority. While we have many platform-wide security measures in place, we believe in a shared security model with our customers. It means that in addition to the platform-wide security features that are baked into AWS, we also provide a rich tool set to our customers so that they can design and build protections and controls that suit their use cases precisely. There are 4 categories of security that we like to talk about with respect to our customers in AWS: network, database, data, and encryption. In conventional hosting situations, customers implement network security using firewalls and by limiting access using route tables and network access control lists. Well, it's not particularly different to do the same thing on AWS. You can run SQL Server in what I mentioned before, an Amazon VPC, Virtual Private Cloud. VPC allows you to define multiple subnets, each specific to an availability zone. You can use routing rules and network ACLs to control network traffic between the subnets and to and from external networks. You can also define ingress and egress rules using what we call security groups. They're like virtual firewalls. And these are useful for preventing or limiting public access. Securing databases and applications is very important, but it's just as important to secure access to your AWS account and your infrastructure resources that are accessible via that account. In a traditional hosting environment, this would be similar to controlling who has physical access to the servers to go in, shut them down, start them up, unplug them, plug them in, and perform other infrastructure-related tasks. AWS gives you a layer of security called IAM, Identity and Access Management, and it allows fine-grained control of any of your services, creation, modification, and deletion of those services, such as creating a VPC or starting and stopping an EC2 instance. IAM lets you enhance the levels of security by enabling multi-factor authentication for users who want to control AWS resources. So one of your options is to use MFA to make sure that that's highly secure. We actually encourage you to take your root credentials to AWS and lock them away and never use them. Only use federated accounts that you create through IAM on AWS. It lets you grant the least required privileges to individuals using groups and roles. And it allows you to enforce strong password policies and rotate credentials, all the kinds of things that you would want for a highly secure resource. You can even federate access to IAM through Active Directory, which is a really nice feature of IAM. In a conventionally hosted environment, there's often no single authoritative log of all the changes that you make at the infrastructure level. On AWS, you have something called AWS Cloud Trail, and that allows you to have a complete and authoritative list of every change that has been made by any user to any resource via the console or via the API on AWS. So it's a complete audit log of everything that's taken place against your systems. Besides access to the infrastructure, database people also need to be concerned with access to the database. It's another security concern. Just like with all database access, it's a good idea to apply the principle of least privilege and grant just enough access to a specific set of data to meet business requirements. And you want to also implement automation to rotate credentials. On RDS for SQL Server, you can actually use the Windows or the SQL Server authentication methods. When you create an RDS instance, you actually specify what we call a master user. And this is a login that you'll only use for administrative purposes. This user is not the SA, but it does have process admin, setup admin, and public roles. And it is in the DB owner group of SQL Server. So that master user has the ability to create additional users and control what types of access those users have. If you're running SQL Server on EC2, you can implement users and privileges however you want, just like you would in a conventionally hosted environment. If you need to encrypt your data, AWS has a number of options related to SQL Server. You can encrypt the data volumes that store your data, and with this model, customers manage a master key for the data encryption using our key management service called KMS. You can also use application layer encryption like transparent data encryption, TDE, or you can implement column level encryption. We also support SSL for your connections to SQL Server on RDS, so you can have your data encrypted in transit. On Amazon RDS, the SSL certificate, the common name, the CN, includes the instance endpoint address, and that's to help guard against spoofing attacks. Next we're going to actually step through what it takes to launch a SQL Server instance. So we start out by going to the AWS Management Console, which is just aws.amazon.com, and then we go to the RDS service, which you can see down there sort of at the bottom left of the pane. Once you click into that, you get the RDS wizard that helps you start a new database. If you click Get Started Now, you will get started. Next thing you do is you choose the database engine. As you can see, we support a variety of database engines. We're going to choose SQL Server, and then you select the edition. Once you've selected one of the engines, it shows you all the editions available for that engine. In this case, we'll choose Standard Edition and click Select for that. Next step allows you to choose what type of HA and performance you need. We'll sort of be able to fine-tune these options later. We're going to select Use Multi-AZ Deployment and Provisioned IOPS, and this directs the wizard to allow us to configure those functions down the road in the wizard. Next, we choose our engine version, like 2008 R2, 2012, or 2014. We can also select a license model. For certain editions of SQL Server, you can use a pay-as-you-go database license, where the license cost is included in your hourly cost. If you don't want to do that, you can also just bring your own license. Start up a SQL Server instance under the auspices of a license you already own. Finally, we're going to define the storage type and size. We allow you to select a variety of different storage performance options, up to 20,000 provisioned IOs per second. We also define the master account for the instance that I mentioned just a short time ago. Next, we have an opportunity to configure some of the more advanced settings such as the authentication type, either Active Directory or SQL Server authentication. We'll choose which VPC and subnet to deploy the instance in, along with specific database options and parameters. You can also just take the defaults, which should be actually suitable for a pretty broad range of use cases. There are also options for encryption, as well as setting the backup window, the backup retention time, and choices around patching and upgrades. Now we're ready to launch the instance. Click Launch DB Instance, and RDS will provision and configure the instance. You can track the status from the main list of database instances. And once the launch is complete, all the instance details will be available. The most important one that you want to look at is the endpoint address. The endpoint address is something that it's basically the address you go to when you want to log into the database. You can use this along with the master user login information to connect to the instance using normal SQL Server tools like SQL Server Management Studio or SQL command. You can also track performance metrics from here or change instance parameters if you want to adjust how the database is set up. Once you have a database running in AWS, you'll want to know kind of how to optimize it. On AWS, you can choose the level of scale of your instances, including like how large of compute you want to allocate, how much memory, what network performance you need, what kind of storage performance you need. All of these can be controlled at a granular level. The first three of these, compute, memory, and network, basically depend on which EC2 or RDS instance type you choose. We provide a variety of types, and each with a different amount of these resources available. Storage performance depends on the type of storage that you choose. We provide facilities to monitor and observe the performance of your EC2 and RDS instances. CloudWatch is the service that we have on AWS that provides you visibility into performance metrics. It also lets you set alarms and notifications in case you are approaching some sort of critical situation. You can use the default metrics that we make available, or if you're running SQL Server on EC2, you can actually choose to publish custom metrics from the instance into CloudWatch. In either of these cases, metrics like CPU utilization, read and write IOPS, memory, and connections, those will start to give you some idea of how the workload relates to the choice of instance and storage that you've made. In addition to CloudWatch, we have an instance attribute called Enhanced Monitoring on RDS. This feature sort of expands on the data provided by CloudWatch and presents additional metrics, 26 more metrics that are available from the Windows operating system on a running SQL Server database system. It includes CPU utilization, read and write IOPS, IO throughput, memory, storage space, number of connections, and disk queue depth. It also has a really nice feature, which is the process list and thread listing. It lets you see which Windows threads are using the most CPU over time. It's kind of like having a task manager view of all of the threads in your SQL Server instance. Thread IDs that you see inside the Enhanced Monitoring part of AWS can actually be correlated back to specific SQL Server connections, specific sessions. If you look them up and if you look those thread IDs up in the DM views, such as DMOS threads, DMOS workers, and DMExec requests. So there's a way to basically translate the top running threads into the top resource utilizing sessions in SQL Server. So this is a screenshot of the enhanced monitoring feature in RDS, some of the graphs, and this is a listing of this shows the process list and all the SQL Server threads that are running. Lets you find out which ones are using the most CPU, and you can go look that number there, like 2912, up in DMOS threads and correlate it back to actual work being run in SQL Server. All right, moving along. When you monitor performance metrics, you might find that you want to adjust some of the characteristics of your RDS instance or EC2-based instance. On the compute side, we offer a wide variety of instance types. Basically, any kind of workload that you might need, we support that, ranging from as small as 1 virtual CPU and 1 gigabyte of RAM on a micro instance, up to 40 virtual CPUs and 244 gigabytes of RAM on our 8x large and 10x large instances. These instances are basically grouped into families that sort of have common virtual CPU and RAM rations and are designed for different types of workloads. For instance, we have micro instances, general purpose instances, burstable capacity, memory optimized, compute optimized, and a variety of other instance classes suitable for a variety of applications you might want to run on them. On the storage and I/O side, there are also a lot of options. Persistent storage is on a service called the Elastic Block Store, EBS, and we call those volumes. And those volumes are divided into 3 classes based on their performance characteristics: magnetic, general purpose, and provisioned IOPS. Most customers tend to use the persistent storage option, EBS, because it remains. On EC2, there's actually another kind of storage that does not remain after an instance is terminated or stopped. And some instances come with this type of disk. It's called ephemeral disk. And for these, the performance and sizing that you get with that ephemeral disk is dependent on the instance type that you select. This storage, I must repeat to you, is ephemeral, meaning that it does not survive termination of the EC2 instance. This is only applicable to EC2. None of this comes into play on RDS. All of our storage is persistent on RDS. But on EC2, you have the option to have this directly connected storage that's ephemeral. So if you use that kind of storage, the fact that it goes away on termination isn't necessarily bad. What it really basically means is that because it doesn't survive termination, hibernation, or failure of the instance, you have to set up some kind of instance durability, some kind of storage durability on there, like mirroring or backups or whatever works for you if you're going to use that type of storage on EC2. Often you can get very good performance out of it, and that's why customers like to use it. Here's a table that sort of shows you an overview of our storage and performance options on storage. The key thing to remember is that your workload will dictate the storage type that's right for you. These options are sort of designed to span the whole spectrum of performance. General purpose storage is based on solid-state disk, and it provides predictable performance as well as a capability to burst performance in spikes. This storage type delivers 3 IOPS per gigabyte provision. So what does that mean? What it means is the larger you build the volume, the better the IOPS performance. General purpose storage can burst up to 3,000 IOPS. Provisioned IOPS is a type of storage that's designed for workloads that need high performance and consistent throughput. You just specify the number of IOPS you need for your workload all the way up to 20,000 IOPS with that storage type. If you're running on EC2 with building a self-managed database or application, you can also take advantage of 2 new volume types. The throughput optimized ST1 volumes provide a low-cost magnetic storage option that defines performance in terms of throughput rather than IOPS. This volume type is a good fit for large sequential workloads such as MapReduce, ETL, databases, and log processing. And then there's another called SC1, the cold hard disk volumes. They're also optimized for throughput rather than IOPS, but they actually have slightly lower throughput than the ST1. SC1 is a good fit for large sequential cold data storage. How about high availability for SQL Server on AWS? If you deploy SQL Server on EC2, it's not particularly different than running it in a conventional hosting environment. You design and implement your own HA strategy in that circumstance using native SQL Server features such as log shipping, database mirroring, or always on. Like we mentioned before, at AWS we have availability zones, and they're physically separate locations within a region. And they have independent infrastructure that are designed to be insulated from failures in other availability zones. Availability zones are really useful for separating primary and secondary servers for maximum availability when you're deploying SQL Server or basically any other kind of application on EC2. You can set up application failover or database failover where you normally do that for hosting SQL Server and take advantage of our separately located availability zones or regions in order to accomplish the type of HA and DR that you want. Unlike on EC2, Amazon RDS provides a fully managed hands-off HA solution when you deploy your instance in multi-availability zone mode. So RDS manages HA for you when you check multi-AZ. It deploys 2 database instances, a primary and a secondary, in different availability zones, and it uses synchronous SQL Server mirroring to replicate the data to the secondary instance. In the event of a failure, the secondary instance is promoted. So multi-AZ, we basically designed it to protect against failures both at the instance and AZ level. With Amazon RDS, you contact your instance using that DNS endpoint I showed you when we were doing the walkthrough. If there's some kind of failure, we promote that secondary instance. We remap the DNS endpoint to the IP address of the new primary and provision a new secondary instance. The whole process is basically designed to take a few minutes from failure detection to recovery. Applications with connection retry logic will reconnect to the new instance when the service is restored. Okay, let's talk about how we manage these databases in AWS and RDS and how we migrate our data into these databases on AWS and RDS. As I've told you before, RDS has a bunch of built-in features for manageability, fully managed backup and recovery, up to 35 days, and we'll do it automatically. You can also take your own self-initiated snapshots of your database, or you can automate this, and those snapshots will actually persist indefinitely until you delete them. For restores, you can recover to any point in time, down to the second, usually up to the last, sometime within the last 5 minutes. Scaling is a part of the platform as well. On RDS, you can scale a database instance class by making a simple configuration change in the console or via the API. Upgrades to RDS are RDS managed as well. You can choose to have us automatically apply minor version upgrades, or have it done automatically, or have it done only when you specify that it takes place. We also monitor your database instances. If we detect a failure, RDS will automatically replace the host. We also provide pre-configured sets of parameters and options that are suitable for most types of workloads. You can change engine settings and easily apply the changes to new or existing instances. Via these groups. So when you create an instance, you specify 2 time windows, a backup window and a maintenance window. And these should more or less correspond to low periods in your workload. The backup window is daily, and that's when we perform a full snapshot of your instance. During this time, some workloads may experience a brief slight impact to performance. The maintenance window, on the other hand, is weekly. This is when maintenance work is scheduled to be performed. So unless you opt out of specific changes like patches or upgrades, or choose to apply your changes immediately when you make them, those changes like patches, automatic minor version upgrades, and configuration changes, scaling operations, they'll all get applied during this window, this weekly window. We only do anything to your instance during this window if there is something to do. We take care also to perform maintenance whenever possible without a reboot. If a reboot really is necessary, we'll, if you're in a multi-AZ mode, we'll fail over to the multi-AZ secondary to minimize your downtime. So how do you get your data into RDS? You can use the SQL Server Database Publishing Wizard or similar tools to export data from your source database and load it into the new database instance. And this is a pretty simple process. It works great if you can tolerate a little bit of downtime and your data set isn't too large. You can use BCP, bulk unload and load tool that comes with SQL Server. You can use our new database migration service, DMS, to achieve migrations with pretty minimal downtime. DMS is a service that we've built that does bulk unload and load of data from your conventionally hosted database up into RDS and also reads the transaction logs to replicate changes on an ongoing basis. DMS is what we call heterogeneous, meaning that it can perform unloading, loading, and replication between different types of database engines, such as Oracle to SQL Server or MySQL to Postgres. We also provide a schema conversion tool to help you translate schemas, such as including objects like functions, stored procedures, and things like that in between engines. So we provide a pretty rich set of migration tooling. Also, if you look at the AWS Marketplace, there are some third-party vendors that also provide similar services. Let's walk through the DMS a little bit. With database migration service, it's actually instance-based as well. It's pretty simple. You start by spinning up a replication instance in your AWS environment. Then next, from within DMS, you connect out to both your source and target databases. Then you choose what you want to migrate. It lets you migrate tables, schemas, or whole databases. Then you sit back and let DMS do the work. It creates the tables, it loads the data, and best of all, it keeps them synchronized for as long as you need. It's that replication capability that keeps the source and target database in sync. That's what allows customers to switch applications over to point at the AWS database at their leisure. So DMS more or less eliminates the need for high-stakes extended outages to migrate production data into the cloud using this graceful switchover capability. All right. So with RDS for SQL Server, let's talk a little bit about authentication. We provide the ability to an RDS for you to use Windows authentication using the AWS Directory Service or Active Directory. You basically establish a forest trust between your on-premises AD and your AWS AD. And then you can domain join your RDS instance to the AD through part of our console, the Configure Advanced Settings option, either when you're creating the instance or you can modify an existing instance to do this. There's another really great new feature called Enhanced Monitoring. Basically, it's, I mentioned it briefly before, it provides you with a pretty rich set of OS-level metrics. You can have these delivered to your own account's CloudWatch logs, which is a service that maintains server logging and other logging information for you. You can get it down to 1 second of granularity. And the only thing about it is you can't get it on any T1 micro or M1 small instances. Compared to CloudWatch, Enhanced Monitoring basically collects metrics using an agent on the database host, on the RDS host. There can be slight differences you might notice between CloudWatch and our collection agent, just due to the fact that CloudWatch collects that data via hypervisor metrics, and we're actually collecting our data directly from the operating system running in the virtual machine. So with that, that is the end of my deck. I have with me a couple of the engineers here in the room who are ready to answer any questions that you might have as well. We have Chaya Pandey, who is the product manager of RDS SQL Server on the webinar and also available to answer questions. So with that, we're happy to take any questions you might have.
Alrighty, thanks Jeremiah, and thank you for a great presentation. They're really informative. Some of the questions we have one which I think you've answered. It was, how do you import and export data to and from RDS or EC2 to an on-premise instance, which I believe you would have answered in your database migration service, but
So,
over to you.
Hamish, would you mind? I turned on the speakers so that the engineers in the room can also hear the questions. Would you mind repeating that question?
Yeah, sure. The question was around migrating data. So how do you import and export data to and from RDS or EC2 to an on-premise instance?
Right. So we did cover that, and there's a few different ways.
Yeah.
One of the ways is using traditional SQL Server tools like BCP and the GUI tools that are available in SQL Server Management Studio and that kind of stuff. But you can also use our new service, like if you want to combine your unload and load into RDS with ongoing replication, so you can basically do a near zero downtime failover from your source to your target, then the way to go is definitely the database migration service, DMS, which is part of the AWS suite of services that we provide. So that's something that you can do with that. And again, there are probably also third-party replication tools you could take advantage of, but DMS is usually pretty competitive with those from a price point of view, and it also is heterogeneous. It can go between different database engine types, so that's kind of nice as well.
Great. All right. Thanks for that. Are there PowerShell APIs to the question was around whether or not there's PowerShell APIs.
There is a PowerShell API for the AWS SDK, so you can use that to.
Okay, yeah, that's true. We basically have PowerShell extensions that allow you to make the API calls scripted up in PowerShell.
Yeah, for all AWS services.
Yeah, basically for all AWS services.
Nice one. We have a question. When can we expect hosting of SQL Server 2016?
That's a good question. I'm not sure we know exactly what the date will be. We will definitely be keeping up with SQL Server versions on an ongoing basis. Although we can't provide a date specific, you can rest assured that we would follow previous patterns with respect to our release time, and we would try to meet or exceed the speed with which we were able to release new versions after the release as we have in the past.
Awesome. We have another question. How easy is it to link AWS cloud applications with our local customer databases?
Right, that's a great question. I mean, it's not just databases, but it's everything you do. And I think what the attendee's asking a little bit about is a hybrid cloud approach, where you have some of your resources on premises or in your existing hosting situation, and you have some of your resources in AWS. We have a lot of ways that you can approach that. You can basically just set up a VPN into your virtual private cloud over the internet if you want to. And the performance of that isn't what you need to succeed with that hybrid cloud approach. We also have a service called AWS Direct Connect, where you're able to get dedicated lines, dedicated bandwidth from your hosting directly into AWS's services, so that you have something very similar to if you were using a very nearby colo provider or something like that. And that's what a lot of our customers who are using a hybrid cloud approach use, is that AWS Direct Connect. Other than that, it's very easy to do your integrations. We like to encourage customers to see their virtual private cloud as just an extension of their existing network, and to treat it as like their existing network, but something that can be expanded and contracted on demand, so that those organizations are not spending that capex on buying servers. Rather, they can take this as a variable cost and only use what services they actually need.
Fantastic, thank you. Here's a more sort of a curly question. What would help people to choose AWS over Azure?
Yeah, that's a really good question. I think you know, it's a bit loaded, and I'll say one thing is that we're not very culturally here. We're not very competition focused, and so many of us here don't really know that much about Azure. You know, from what I understand, you know, they don't have nearly the level of scale that we do, but I only know that from the Gartner, the Gartner Magic Quadrant that that we mentioned earlier on in the presentation. So I really don't know in a lot of detail what the pros and cons are of Azure, and you know, I really leave it up to the customer to make those comparisons. I will say the breadth and depth of our services is pretty large, and we did get started something like 6 or 7 years before most of the other folks got into doing cloud computing. And so our head start, what that translates into is maturity. Our services are numerous, our services are deep and highly functional, and they're mature. And that maturity means that you're not treading on virgin territory, and nobody wants to tread on virgin territory with enterprise applications. I guess that's sort of my take on it.
No, that's a great answer. Thank you. Is Amazon SQL Server and RDS HIPAA compliant? I'm sorry, I don't know what HIPAA compliance is.
It's a U.S. Regulatory governance acronym. So with respect to HIPAA, we provide you with all the tools that allow you to be HIPAA compliant within your own applications. Of course, it's also up to you to implement the regulatory elements of HIPAA. But if you go and if you just Google AWS and HIPAA, you'll see all of the different compliance capabilities that we have. We've made it absolutely possible for our customers to be HIPAA compliant on nearly all of our services.
Fantastic. We have one last question, and for the attendees, please feel free to put more questions up. The question is about what % of Amazon does AWS represent?
I'm not sure what metric is being mentioned. As you know, we now split out AWS in our quarterly financials. So if you want it by the numbers financially, you can go and reference our various quarterly releases that we've made to the FTC. Other than that, I'm really not sure how to characterize and answer the question. We're a significant organization within Amazon, but Amazon remains a diverse company with many different divisions doing many different interesting things, and AWS is just one of those.
Yeah, appreciate that. It's coming up almost 5 minutes to the hour, so if people do have any more questions, please put them in, and we will answer those before we end the session.
So one thing that I'll just add, and I don't know, we didn't have that earlier on. We had my Twitter handle, which is @auradebug, but I'll also just mention my direct email address at Amazon in case anybody has further questions that they'd like to follow up with me or with any of the other engineers here. We'd be happy to engage with you on any specific questions that you have. My email address is easy to remember. It's just jeremiah@amazon.com, JEREMIAH @amazon.com. It's one of the perks of showing up early is you get your name or an email address.
Fantastic. Alrighty. We do have one question. It is, why should we move to a cloud solution like EC2? It's a fairly broad question, so I'll leave it to you to answer.
It's a good question. I like that question very much. I mean, so people have a lot of different reasons for wanting to move to a cloud solution. I mean, probably the biggest one is what I mentioned just in one of the previous questions, is that it's elastic. You can use or not use it based on your needs and your demand. So while companies have a lot of demand at one part of the year and no demand at another part of the year, we happen to be one of those companies. So we understand that problem very well. We like to provide you with a service where you can use a little bit of compute or a little bit of memory or a little bit of storage or a lot, depending exactly on what you need to do. You're in complete control of your spend and your costs. Whereas if you're in a conventionally hosted environment, there's a lot more commitment to be made. You have to requisition servers, have them built, have them put in place. You have to invest in those services or lease them. You have to get floor space in a co-location center or a data center. And that's not agile either. It takes a minute to provision an EC2 instance or an RDS instance, maybe a couple minutes. It takes weeks to provision a piece of hardware from your IT department and have it installed, configured, and put together, even if they have a lot of their stuff automated. So, you know, we provide that agility, we provide that variable cost. You know, we're fully managed for a lot of our services. The services are highly resilient. We provide geographic capabilities, so high availability across regions, across zones. So these are all the kinds of things that hopefully really make you think that it might be a better idea to use a generalized commodity compute and cloud service like AWS versus trying to build your own. We want our customers to focus on whatever capability is their wheelhouse. And most of our customers, who are banks and pharmaceutical companies and manufacturing companies and these kinds of organizations, their core mission is not building IT server farms. Their core mission is doing that main business that they're involved in. So we want to provide a highly affordable and an easy to control way to offload that for them so that they're not doing stuff that they're not even meant to be doing.
Nice, nice. We have a question. Is RDS SQL Server appropriate for a 5 nines, you know, 99.999% reliable environment with only tolerance for a 10-second blocking? Thinking maintenance, replication, that sort of thing.
I think that if you wanted to build a service like that, I mean, first of all, I'll let my engineers here field that. What do you guys think of that question? Can we meet that number of nines with RDS, or should the customer go with an EC2-based solution instead?
No, we can definitely meet that with RDS.
Okay.
We don't officially have an SLA for our high availability for RDS SQL Server, but with mirroring, you're on 2 servers and 2 different AZs, and with the proper application architecture, that can be supported.
Okay. What is the failover time typically between AZs for multi-AZ mode on a SQL Server?
So for RDS SQL Server, multi-AZ is implemented using mirroring. So it's actually the mirroring's failover is pretty much how much time it takes, and that can vary and it depends on the workload which was happening on the instance before the failover. Typically, we have seen failovers take from 2 to 3 minutes, and if the only other extension to that would be the crash recovery time, which takes.
All right, thanks for that. So you know, I think going by nines is not always my favorite way of trying to measure the metrics around availability. I prefer to have a very specific RTO and RPO number that the application requires. Based on RPO and RTO, in any individual case, we can look at the way the application works, look at the rate of change that the application has, look at the you know, various other attributes of that application and the workload on the database. And we can probably make a good determination on a case-by-case basis whether that's a good fit for RDS and our multi-AZ mode, or whether it's something where the customer might want to engineer a solution on EC2 using their own approach to high availability and DR.
Fantastic. Thanks for that answer. I think we'll make this the last question because we are on the hour. What security variation does a private or public cloud have?
Variation?
Yes.
I'm not sure how to answer that question.
Yeah.
So we did have a slide on security, and I know that customers are often concerned with security. I guess I'll say this. I used to think, can you hear me? Oh, there we go. I used to think that there might be a security compromise involved in going to public cloud like AWS. But the more I looked at it, the more I realized that AWS and AWS resources are built more carefully and with more security capabilities than the data centers that I used to run my workloads in. This is, in between. I'm a boomerang to Amazon. I worked at Amazon before I came back. In between, I was consulting. I was helping companies do manage their services both on conventionally hosted systems and on the cloud. And as the cloud came to become more mature, I came to realize that AWS actually had better physical security, better data security, and better security features in the cloud services themselves. Then we were able to implement ourselves on-premises systems and on colo systems. I had one colo that I worked with where I went to visit the engineers at the site, and I walked in through a back door and was able to go directly into the server farm without passing any kind of physical security. And I was appalled. Nothing like that ever happens at AWS. AWS has some of the most locked down security of any infrastructure provider in the world. All you have to do is attempt to get near any one of our facilities, and you'll know that there's absolutely no way to physically penetrate these systems. And our software approach is similarly paranoid. This part of Amazon's culture goes back to our earliest days as an e-commerce provider. People used to be so paranoid about buying things on the internet that they wouldn't type their credit cards into an internet browser. Instead, they would call us up on the phone and give us their credit cards by voice, thinking that was more secure. Now we all know using SSL and secure websites is a better way to do that and more secure than announcing it over a telephone line to people. But it's a similar evolution of perception and culture. So that's sort of how I look at it.
Cool. Alrighty, thank you very much. What we might do is go on to the next slide, and please thank you everyone for attending today, and thank you for the great questions. Make sure to stay tuned for our next session, SQL Server 2016 Reporting Services and Mobile BI with Ricardo Muti. And thank you all very much for attending. Alrighty.
Take care, everybody. Bye now.
Thank you, Jeremiah.